I didn't get much sleep over the weekend.
Why?
I had to go back and forth to the hospital like the other day. My grandma went to the hospital. She's back now.
Thank you.
No worries.
I'm not even sitting down yet, so.
Wow. The question is, do I go to the restroom before class or do I wait until the middle of class?
So guys,
Great.
go now. Run.
Well,
Yes. I think we were calculating modular elasticity for like when we're trying to see something.
I'll just tell them you're officially on Facebook. For the school.
Oh my gosh. What's up?
I don't have an A on Friday because I gotta go do all region. So that's a double.
Nice.
I don't have to do chemistry and pre-cal and English.
No, you still have to do them.
I don't have to do either of them.
It just depends on how much they can get here.
Luke.
Was 65 the homework we did last time?
Yes.
Oh, I did that.
Yeah. One of the classes, I told them that they could finish it the next time. So.
Your website's awful numbers. The solutions for 65 is like 64. Unless
Oh, it was 60.
mine is wrong, but then oh, that's what Diego was asking about or something.
I can check it later. Okay, so there was only one handout this morning, but it is actually two numbers for your binder. I just put them on the same piece of paper. 66 is the front and 67 is the back. So just a couple notes and a couple questions to practice. These questions are a little bit longer, so that's why I'm not giving you as many to do. But I feel like it's been a while since we've had any A days, just giving B days a chance to catch back up. And actually, I guess they pulled ahead a day. So, but since we have come back from winter break, we have spent 3 days on law of sines, law of cosines, if you include the day we quizzed on it. And again, that was really just for you for the ACT. And then we have spent 2 days on limits. The first day we spent on limits was learning what a limit was and how to find a limit from a graph. And then the second day was how to find the limit from a function and how to deal with what happens when you get 0 over 0. So that's what we did on number 6, handout 65. But when we dealt with 0 over 0 last class, the only thing you had to worry about was factoring. Today we're going to look at 0 over 0 with 2 different methods. And Friday we'll look at 2 more methods. So that's kind of what we are building up towards. So the front, which is 66, starts us off just as a gentle reminder here. When you're doing limits like this, you should always start with direct substitution. So try to just plug in 3 everywhere there's an X. Hope that you get a real number, because if you do, you can quit. You were done. When you plug in something like 0, what happens when we try to take a number like 5 divided by 0? Okay, so that would be undefined, so we would say the limit doesn't exist. Can't divide by 0. But the problem that sometimes occurs, oftentimes occurs in calculus, is you start saying, okay, well, all I got to do is plug this number in and get an answer. Sometimes, yes, but sometimes your numerator goes to 0 and your denominator goes to 0. And then this poses a problem. Because if you take 0 divided by any other number, you get 0, as long as it's not also divided by 0. If you have any other number, like we saw up here, 5 over 0, then that doesn't work, it's undefined. Also, you've been told that anything divided by itself is 1, but really 0 over 0 can go to anything. Could be 0, could be undefined, could be 1, it could be 5 over 2. We have to do more work. So, this is what we refer to as indeterminate form. It has not yet been determined. So last time, all we had to do was factor the numerator and or factor the denominator, get something to cancel, and then we plugged it back in and did direct substitution again. So today, we will also get something to cancel and plug it back in, but not everything is going to be a factoring type of question. So notice this question is the same as this question down here. So let's actually go ahead and work it out. So you get 0 over 0, and then as we go through the next few class periods, mentally you should be making a list of things to consider. So factoring would be the first thing, it's the most common one, but the numerator doesn't factor, the denominator doesn't factor, so as much as you may want this to be a factoring type of question, it's not a factoring type of question. So we need to use this mathematical trick called multiplying by conjugates, and I suspect you guys have probably heard of that word in Algebra 2. I'm seeing some yeses. You
I forgot.
I can't really remember what all it is. But
Okay, that's fine. It's easy to know what a conjugate is, but even if you did see it in Algebra 2, and even if you remember it, you probably didn't see any examples of where conjugates are actually useful in mathematics. So conjugates actually show up in a lot of different ways, just kind of a unique trick to make things work. Limits just happens to be one of them. So you're going to take the part that has the square root, whether it's the numerator or denominator, and we are going to multiply the top and the bottom by this guy's conjugate. And all conjugate means is you switch the middle sign. So square root of x minus 2 becomes square root of x plus 2. That is its conjugate. Now we have to multiply the top and the bottom by the same thing, because when we do that, it's like we're multiplying by 1. Anything divided by itself is 1. So this is a tool to change the way this looks without changing its size. So that's all a conjugate is, and then it just works from here. Now the questions are still going to need a few more steps. We're still going to have to remember some other previous knowledge, but truthfully, right now, we are already done with the calculus. Knowing to plug this in, knowing how to deal with 0 over 0, and knowing that conjugate is a strategy that sometimes works. But to move forward from here, we need to review and recall what it means. How are we going to multiply these fractions together? So, how do you normally multiply fractions together?
After the x minus 4.
It's still there. It's all of this times all of this. This is a time symbol. It's still there.
Oh, okay.
Oh, it's already multiply. Okay, so multiply straight across. So we're going to multiply these two terms times these two terms. And what do we normally call that if we multiply two terms by two terms? Trinomial is when you have 3 terms. Quadratic is when your degree is 2. This is a binomial, yes, but what is it called when you take it binomial times a binomial? There's a process.
Multiplication.
Okay, so most people know this is FOIL.
What?
Okay, so square root of x times square root of x is going to be
X.
x. The same way the square root of 3 times the square root of 3 reduces to 3. The same way the square root of 5 times the square root of 5 reduces to 5. You could do the outer part of FOIL and get 2 square root of x, and then the inner part of FOIL and get minus 2 square root of x. And I'll give you a little bit of a tip here. Last part would be minus 4. The outer and inner part of conjugates always cancel each other out. So I don't even usually do that. I usually just skip those two because I know they will cancel each other out. If you want to memorize that, you can save yourself a touch of work. And if you don't, you'll just have to do like I did and cancel them out. Okay, you might be tempted to also multiply across for your denominators, but you don't actually want to do that. You want to say you've got an x minus 4 times this stuff. And why do you think I'm not multiplying this stuff together? Right, so now we're seeing some similarities to the factoring part. Last time, after we factored, we wanted something to cancel. This time, after we multiply by conjugates, we want something to cancel. X minus 4 cancels out with x minus 4. And then just like with factoring, as soon as something cancels, direct substitution should now work out fine. If there's nothing left in your numerator, that means it's a 1. Plug 4 into what's left over. And if you are left with a real number, you can assume that that is your answer. Okay, so multiplying by conjugate is just a mathematical trick that sometimes makes it look different, and it just works. So limits just happens to be one of those things. Okay, so one more of these, and then I'm going to ask you to flip it over and try one before we look at the second method today. So what's the first step in limits?
Multiply.
You got to say it louder.
Multiply by the numerator with the flip sign of the numerator. Flip sign.
Okay, you could do that in this question, but you're going to waste a lot of time and probably get either confused or the wrong answer.
Plug it in.
Always start with direct substitution, because in this problem you end up with 0 over some number. And what is 0 divided by a number other than 0?
0.
So remember, direct substitution, you always need to start with that. Most of the time the question is 0 over 0 to help you practice what you need to practice, but always try that first. Okay, so for you to get a chance to try this and see how that goes and hopefully eliminate a few common mistakes quickly, if you flip your page over, question 1 is a conjugate question. So I'd like you to try the first couple steps. Do what you think you should do based on the example that I just did. Not the last one, but the one before it. We will check the first part of the question together to make sure that that's right, and then I will ask you to try to finish the question once you're sure the first part is correct. And these type of questions are usually a little bit harder for people at first, so don't be discouraged here. That does get easier after you do a couple, because they all do follow a very similar pattern. check in just one more minute, so just do what you can.
Are all of these conjugates?
Most of them on the back page are. There's one other thing we're gonna look at today that's not conjugates, we just haven't talked about it yet. Okay, let's check the first part and then I'll give you a moment to try to finish it, but let's make sure that that's okay. So, I tried to show you from that second example on the other page that you should definitely, even though it doesn't seem to matter a lot of the times, you should always start off with direct substitution. Make sure you get 0 over 0. If you don't get 0 over 0, you don't have to do all this extra work. And even if you do, it is going to make the question longer and more confusing. But you only have 2 strategies right now, factoring and now conjugates. This doesn't factor, so your only other option is conjugates. You always want to do the conjugate of the one that has a square root. So it's not necessarily the numerator, it could be the denominator, but all conjugate means is the exact same thing, but change the middle sign only. So not this sign also, just a -1 becomes a +1. Okay, so I don't know if it's a satisfying answer, but our calculus is finished. Really all we're doing now is multiplying fractions, and they're kind of messy. But to multiply fractions, we need to multiply the numerators together. So 2 terms times 2 terms, most people are going to call this FOIL. The square root of 2x minus 5 times the square root of 2x minus 5 is just going to be 2x minus 5. You're welcome to do the outer part of FOIL next, and then the inner part of FOIL after that, but those two always cancel out, so I'm going to skip them. And then the last part of FOIL, -1 times +1 would be -1. Even though you can FOIL the denominators together, it would be a mistake, because we need something to cancel out, and if we multiply all this mess together in the denominators, then we're not going to see what's going to cancel. So if you did the conjugate correctly, and you multiplied your fractions correctly, you should have gotten to this step. So before I ask you to try to finish it, what else could we maybe do to the numerator?
You could combine -5 and
Okay, so go ahead and combine like terms.
and then you could split. You could factor into 2 times x minus 3.
Okay, so you could factor out a GCF, and how did you even know to do that?
Because it contains x minus 3 and I can cancel it by 2 or something.
Okay, so the fact that you know something should cancel. Okay, and then try to finish. I know we almost finished it, but after you get something to cancel, think about what you need to do and then try to come up with a numerical answer.
The reverse sign is always the very last.
I'm sorry?
And the conjugate is the reverse sign is always the last one.
It's the middle sign.
Middle sign.
This sign in the middle becomes a plus. It's not necessarily the last, because on number 4, you're not changing this to a plus, you're changing this to a plus. You've got 2 terms. You got this big term and this big term, and then you got to add or subtract in between them. Change that and you get conjugate. But it's not necessarily the last. Okay, so the moment that you get something to cancel like this, you should know that you're on the right track and you're almost finished. We started off by plugging in 3 and trying to get an answer. It just didn't work. We did this work to make something cancel, and the reason we wanted something to cancel is because what's left behind should work. So in the numerator, we only have a 2 left over. In the denominator, if we plug in a 1, it looks like that goes to 2, and 2 over 2 should go to 1. Final answer to that one should be 1. Now, I had mentioned this with the factoring, and I'm going to repeat it again. with the factoring, you guys had a lot more questions because they're a little bit quicker to do, I think. These take a little bit longer. You need to work them a little bit slower to not make a careless mistake. You don't want to be making arithmetic mistakes and having to start these questions over from scratch. But what I had suggested to you as a way to check, and I'm going to ask that you do at least a couple like this today, or maybe all of these, because there's really not that many on the back page. But you can graph this in your calculator. You can graph all of this. I'll do it for you up here. You can do the next one. But if you graph this, it's going to show you what the graph looks like. And don't use this as an answer getting strategy, but you should be able to check your answer, because now this is what we did day one. How to find the limit given a graph. So if you jump to x equals 3, it's going to say y doesn't exist. That's okay. That's correct. But limits do not care what's happening at x equals 3. They care what y value is it approaching. So if you move your cursor just a little bit to the left, you can see the x value is getting closer to 3. What does it look like the y value is getting closer to? Okay, move the cursor a little bit to the right of 3. So as x approaches 3 from the right, what does it look like the y value is approaching? So if it's approaching 1 from the left and 1 from the right, it should make sense that your limit is 1. So I think that's good for you to do a few times, because it connects that first day stuff with what you're doing now. We're just doing it without a graph because we don't know what this graph looks like, and you often don't have a calculator, especially in calculus. Okay, flip over back to the other side. So this is one method. This is the main thing I'm going to ask you to practice in a few minutes. But also, we're going to look at one more method today. So the start, end of these questions are going to be the same, but the way we get creative and make these look different, it's just going to be a different strategy. So we're still going to start with direct substitution. We're going to hope that we get an answer, but if we get 0 over 0, we got to think of a creative way to make this look different. So mentally, I'm going through our list of things that we've learned. We've done factoring. Does it look like either of these factored? Then we've learned conjugates. I don't see any square roots. I don't see 2 terms in either of those, so this is not a conjugate. So this one, we need to use some kind of trig identities to make this look different. Now, to be fair, this first question, you don't know this trig identity because we didn't do this last semester. But if you end up taking Cal BC with us at the high school, or you end up taking Cal 2, eventually someday you'll have a teacher that expects you to know this identity. But just trust me that sine 2x is the same thing as 2 sine x cosine x. So assuming you knew that identity, and again, you don't need to know it for this class, we're just using it as an example, we can make that substitution. And why is that helpful? All right, now it's going to finish like all the other ones we did. Something cancels, and it's the second that something cancels, plug into what you have left over. And if you end up with a real number, then you were finished. So sometimes changing something, some type of trig thing, into something else is a different viable strategy. So you did not know that one.
Where'd you get the 2?
I'm sorry?
Where'd you get the 2 and the 1 from?
This 2 is this 2. Cosine, when I plug this in, cosine at 0 is 1. You guys are still on the hook for unit circle. Unit circle is not going away. It's fine if you need to slow down and think about it, but you got to be able to get it right. Most important thing we did last semester. Okay, number 2, if you plugged in pi, this goes to 0, this goes to 0, so you do get 0 over 0. So in my head, I'm thinking factoring first, because that's the most common way. I'm thinking about conjugates, but this doesn't look like a conjugate question. But it does have trig stuff in it, so it's probably a trig identity. So which one of these things do we often change when we're dealing with trig?
Tangent.
Okay, and how do we often make tangent look?
Sine over cosine.
Okay, so I don't know if sine over cosine is going to work, but it's a fair attempt. It's a good thing to try.
It's just
In fact, if you guys remember doing the trig proofs last semester, where we made one side look like the other side, the left side look like the right side, it was really for questions like this. It's not that you have to make this look a certain way, but you have to have some experience saying, hey, I could make this look different, and let me see if that helps, and if not, maybe I'll try to make something else look different, see if that helps. But if you think to make that substitution, what I highlighted, then you can say times cosine divided by cosine cancels. Since something canceled, you're welcome to try direct substitution again. Unfortunately, we still get 0 over 0, which just means we need to do some more simplifying. So, what is sine divided by sine? 1, because anything divided by itself is 1. So something else is canceled now. So we can try direct substitution again. And you can try to plug pi in everywhere there's an x, but there are no x's. So the answer is just 1. No matter what you're approaching, it's going to be 1. So different way to make that stuff look different so that something cancels, and then once something cancels, we can do direct substitution. So let's do one. There's only 2 of these on the back page. These are just kind of harder questions to find good ones for. But if you'd flip your page over, let's give you a chance to try question 6. So same thing. I'll give you a minute or 2 to try the start of 6. We'll check it, and then I'll give you a minute or 2 to try to finish it. That way, if you get stuck or you make a mistake, you can still make sure that you understand how to do the last question. Then we need to talk about CAP and make sure that you guys get a chance to ask questions about the math courses that you have to pick from. Then you'll have some time to finish this up. And that will be the lesson for today.
Will the trig functions be on the test?
Why wouldn't they be?
These actually make me think. It's hard.
Sounds like we should put more of them on the test then.
Oh, no. They're actually super easy, and it would just be a throwaway test for you.
Why don't you go ahead and start this one? Okay, let's make sure that you're not stuck at the beginning so that you can try to finish the rest. So you should have tried plugging in 0, but the cosine at 0 is 1, which makes the numerator go to 0. The sine at 0 is 0. You square 0, you still got 0. You times it by 2, you still got 0. So this is 0 over 0. So you think of your list of things to try. Doesn't look like anything factors. I would say we don't have any conjugates because there's no square roots in here. So the only other thing that's on the table at this point is trig identities. So does this numerator look like any of our trig identities that we know? Kind of close, but not exactly. But what about this? Okay, what is sine squared equal to? Very good. So the first Pythagorean identity is by far the most common one. And so If we solve that for cosine squared, it's the same thing as, sine squared, it's the same thing as 1 minus cosine squared. That's the substitution you needed to make to try to move forward. Now, I will warn you, right here, it is very tempting to make these 1's cancel and or make these cosines cancel. But that's not how fractions work. You don't get to cancel out terms, things that are being added or subtracted. When you reduce a fraction, you are only canceling out factors, things that are being multiplied or divided. So, I know that something's supposed to, in the numerator, is supposed to cancel with something in the denominator. So that gives me a hint about part of what the denominator needs to look like. But really, what should we do with this?
Difference of squares.
Very good. It's a little bit harder to see, but it is the difference of squares. You've got 1 being squared on the left, cosine being squared on the right. Difference of squares is a plus and a minus. And you had a little bit of a hint because you should have known something was supposed to cancel. Okay, so I almost finished it for you, but see what you would do from there. Okay, I'm plugging in 0 into this stuff, and I'm going to get 2 times 1 plus the cosine of 0. And what is the cosine of 0? So 2 times 2 ends up being 4. Very good. If your numerator all goes away, it doesn't just disappear. It doesn't make your denominator your numerator. If all of your numerator goes away, it's a 1. And how could we check this answer? You could graph this. Now, just fair warning that if you do check the other one like this, you must be in radian mode. I know we do quite a bit of stuff in degree mode in here, but all higher mathematics is always in radians. So if you want to graph this in radian mode and look slightly to the left and right of x equals 0, you should see the y values approaching 1/4 from both sides. That would be your confirmation to know that that's correct. Okay, so before I give you some time to try the rest, I want to just make sure that you guys have a chance to see. I know you've been doing CAP stuff in advisory, or you were supposed to be. And with math, especially once you guys get to this level, you've got quite a few choices, as you are considered a 4th-year math student. So these are all the things that we are offering next year that you get to pick from. Of course, some of these I think are much more likely for you guys to pick from, but the main one would be, for most people, would be AP Calculus AB. That's kind of the point of you taking pre-calculus. Pre-calculus is a lot of work, first semester especially. Learning all that trig, learning a little bit of calculus the next couple weeks, and then all the algebra we review the rest of the year is all trying to set you up to make calculus be manageable. So most of you should be picking this. I would say if you know what you want to do after high school and it doesn't require calculus, then maybe you wouldn't sign up for calculus. But if you are not sure, or you have doubts, then you probably should move on to that. Most people change their major in college like 4 or 5 times. So you may not think that you need calculus, but someday you may change your major and then you do need calculus. And if you take a year, 2 or 3 off from pre-calculus to calculus, you're going to remember the unit circle and trig identities and all that kind of stuff even less. It gets harder the more years you take off from it. So that's one thing to consider. So I can speak more on that in a minute. AP Stat is also a pretty common choice. Not so much this year, but most years students would say that have been in both would say that AP Stat is an easier course. I've not heard that as much this year. But I can tell you that the pass rate for AP Stat is about the same as the pass rate for AP Calculus. So even though some years the class may seem easier, the end AP test trying to get the college credit is about the same. So AP Stat, I don't know too much about it. I've never taught AP Stat. Ms. Bramlett does. But of course, for all of these courses, if you guys have friends that are in those, you know, asking them like, how hard is it? How much work is there? Trying to figure out if it fits in your schedule. Is it something that you're interested in? All of that is good stuff. But Ms. Bramlett's the one that teaches it, and she is in room 2901. So if you have a specific question that you don't think I know the answer to, or your friends that are taking this course don't have answers to, she would be happy to answer that for you. And this is her quick little summary of what the course is like. Hello? Yeah. For who? AJ? Oh, Haley. Okay. Yep. Haley, you checked out at 2:15. Do what?
No.
Okay. So this over here is what she said about the course. I know statistics is becoming a bigger deal if you're going into business. So that's something to consider. Yeah.
Sorry, my advisor's been out like this whole week, so I haven't really been able to ask him, but do you know when the sign up when it closes for like classes? Because he said we were gonna do it this week, but I don't know if like.
The last day that you can make changes is the day of the CAP conferences, which is like March 8th or 9th or something.
I think it's like March.
Oh, okay, 18th, 19th or something. There's 2 CAP days that you can choose to go to, but that's really your last chance. You should come to the CAP conference and make changes if you need to, and if you don't need to, then you've signed off on it, so. But you should be, whenever your advisor's back, I would still start moving forward on the process though.
Yeah, I was just making sure I have to talk to him about it.
Yeah. The other one would be college algebra. It's a pretty common pick. College algebra is a 1-semester course. After you take college algebra, you could take one of these 3. I will tell you that Survey of Calculus and College Trig have not offered the last few years. If we don't have at least 15 students request a class, then we don't offer it because it's too expensive to have a teacher teach a class of just like 3 or 4 students. So those don't often make. This is the one that really surprises me though. What we do in pre-calculus first semester is probably about 80-90% of what you need to know in College Trig. I mean, you're going to start over with the unit circle. They're going to show you the trig identities again. They're going to show you graphing sine and cosine. And that stuff, seeing it a second time from scratch is it's a lot easier because you go into it, you know, knowing some of it and remembering a lot of it, and I think it's easy college credit. But for whatever reason, students still don't sign up for it. So yeah.
Would Cal AB and Cal BC credits, AP credits, be able to let you skip those college classes?
It kind of depends on the school and how you do on the AP exams. If you take the AP courses and you pass the AP exam, then they're not going to expect you to backtrack and do college algebra. But if you didn't pass the AP exams and your ACT math score is lower than a certain number, then yes, they would still make you take college algebra. Yeah.
What is survey of calculus for college?
Survey of Calculus is like Cal AB, but a little bit easier. It used to be that if you were a business major, they asked you to just do Survey of Cal instead of Cal 1. So if you knew you wanted to be a business major, I would probably aim for this one. The problem is that we don't usually offer it because we don't usually have enough students ask for it. But it could be. I mean, I can click on it. This box is just the same thing as from the CAP book. Miss Rogers teaches our NWAC courses, so she would probably be the best one to talk to about it. But again, it kind of depends on what your major is going to be and what school you want to go to, how much calculus they expect, if they expect any calculus. Because again, some majors want, if you want to do engineering, they're going to want Cal 1, Cal 2, Cal 3, and differential equations. If you want to do business, it's probably either Cal 1 or at least survey of Cal. But it's a slightly easier version of calculus. Usually less trig in it than other calculus would be. Now, this part, I don't know if this is still true because I can't keep up with all of it, but as of a couple years ago, at least the U of A here in town, if you had a 26 on your math ACT score, then they would give you college algebra credit. So if you were considering signing up for college algebra, I would Google search whatever schools you're thinking of going to, college algebra, ACT score, and see if they're going to give you credit. Because at the high school, we have no idea where you're going to school, what your plans are, what your ACT score. Well, we do know your ACT score because you have to have a certain score to get into the course. I think you have to have a 21. But it'd be a shame if you got like a 26 or higher and you pay. The course doesn't cost very much, especially compared to taking it at the university. But taking it and doing all the homework and studying for the test, and then you come to find out later on that you didn't really even have to do all that. The school is just going to give you credit, would be a waste of your time. But most people pair up college algebra, if you're going to do that, with finite because they are both one semester courses. When I went to school, every major required at least those two. So even if you were like a history major or a art major and you wanted nothing to do with math, everybody still had to have college algebra / finite. And finite is a little bit different. It's some like probability and some logic, and it's not necessarily harder, but it's just a lot different. At one point at Walmart or somewhere, I had found this like, you guys seen these like cheat sheets? They're like, just give you kind of like the important stuff of the class. Anyway, so I bought this if you want to ever scan it to see what finite is like. You can do that. But anyway, those would be the three main choices. But the other ones are fine too. Maybe you want to learn some statistics, but you've already got 3 other AP courses on your schedule and you know that you're going to be too busy. Then there's nothing wrong with statistics. I don't know as much about it, but I'm happy to click on it for you guys to see what the teacher said about it, who teaches it, in case you want to go ask them questions. I can do that for any of these classes. The main thing is I just want to make sure you guys pick the course that is what you actually need and want. The worst thing is for you guys to get into class next year and then regret that you should have taken this or you should have taken that. So, is there any of these others you'd like me to pull up to look at? Okay, so again, I guess I will say about the AP Calculus, as I have mentioned in here thousands of times probably, calculus is difficult. It is more demanding in this class. It is usually more stressful for people, especially for people that are always just used to math coming easy to them. Calculus doesn't always go that way. I'm sure you guys probably have friends that are in calculus and they tell you it's hard. Yes? Some? And it's true. Like I said, it is demanding. It is not a blow-off class. It is not an easy A. But that being said, last semester, some of that gets blown out of proportion. So I want to make sure you guys are aware how calculus is different than this course to help you make an educated decision. But also I'm not like trying to scare you off from it, and don't let your friends scare you off from it. Last semester, I have 2 calculus classes this year, and last semester one class had an 89% average at the end of the semester, and the other class had an average of 93. So, it's not that it's impossible or anything, but it is quicker, more demanding, can be more stressful than pre-calculus is. So, you just need to know what you're getting into. That's all. Okay, no other questions? You guys know what you want to take? Okay. If you think of anything in the next couple weeks, then please go ahead and ask. Again, even if I don't know the answer, I will do my best to find out. Because, again, the worst thing to me is that you guys pick a class and then you find out, hey, I really should have taken this and I just didn't know. I just didn't have a, I don't know. I just don't want you to pick the wrong thing. So if you do think of anything in the next couple of weeks, then please ask. Okay, so to finish up class today, we did one conjugate pay question on the back, question 1, and one trig substitution, number 6 on the back. So it looks like you have 4 more conjugate questions and maybe one more trig question. And again, I do suggest that you guys practice graphing to check your answers. But that is not many questions here, so we are certainly focused more on quality over quantity. So let me set a timer here, and about 10 minutes from now, I will let you tell me which questions, if any, are giving you issues, and I will help you get unstuck from wherever you're at. And this one you should certainly finish in class. But
Is there a way to put like cosine squared in?
you do cosine x in parentheses and then put the square. If you do it like this, it's going to square the angle, which is not what you mean. What you want is cosine. It's not how we write it, but it's the closest thing that your calculator can do.
We want to plug in what x is from instead of just x.
What are you trying to do?
Just plug in the equation.
For what?
So
You're trying to graph it, you mean? No, you actually want to put in the x's, graph it and see what it looks like. Here's where I did question 1. Question 1 wanted to know as x approaches 3. Get busy. The whole thing. And you graph some to check your answers?
No, sir.
Okay,
Well,
then you can
grabbed
do
the
that.
ones I was going to.
So as x approaches 3, then you just look around there. Around 1, around 1. But when you graph it, you still leave the x's in there.
I was just waiting to ask since it didn't really pertain to the group, but I think I want to do major in computer science of some sort. Do you think calculus would be like the best thing for that, or do you think
To be honest, I don't know.
maybe I should probably ask
I
the
think,
science teacher?
yeah, maybe that, or again, just Google search computer science majors, do you need calculus? And it's probably going to tell you pretty quickly if you do or not. So, yeah. Sorry, I just don't know.
No, I thought
Aren't you surprised that I got my work done though?
No.
Good.
Can you fix my Zoom thing here? It's like all thick and doesn't
Okay.
look like
So you could either A, you need to know how to fix it. You go to Window,
window.
and you could change these numbers to the numbers you're used to.
Mhm.
Or what's a lot quicker is if you go Zoom 6, tells it to put it back in standard,
Oh, okay.
and that's a lot quicker.
Gotcha. Thank you. So is each little dot 1, 2, 3, 4, 5, 6, 7,
Yes, it should be negative 10 to 10 and negative 10 to 10. So each little tick mark should be 1 if you're in standard.
Can I ask what you got on 3?
I don't know what I got on 3. I think 3 over 2.
3 over 2.
I think. But I'm also doing it super quick and not. I'm not really like showing all the work there. But I've done thousands of these before, so I can be a little more confident in what I'm doing. But I think it should be 3 over 2. So when you're checking yours in your calculator, did you graph all of this?
Yes.
Okay, and then if you like go to x equals 2 on the graph,
Oh.
so I usually do trace negative 2 enter, and it jumps to negative 2 a little bit quicker. You got 3 over 4?
Yeah, I
Me
do
too.
too.
Okay, like I said, I was doing it super quick, so.
Oh, no worries.
In fact, I can show the graphing again because we've been getting a few of those questions. So.
I got 3 over 4. So
Okay, so that's what I'm getting when I graph it. You're getting that?
Yes, sir.
Okay, so again, it's like I really care about this, and it's such a small little window here. Like mine's on the big screen, so it looks a little bit easier. But when you're looking at your tiny little window there, it's hard to see. So if you do trace negative 2 enter, it will jump to that spot on the graph. I don't really care what's happening at negative 2, so I don't care about this value yet. But if I move the cursor to the left a little bit, this would be as x approaches negative 2 from the left. It looks like y is getting closer to about 0.75 maybe. And then move the cursor to the right of negative 2 just a little bit, the best that you can. And it looks like y is also approaching about 0.75. And since it's approaching 0.75 from the left and the right, it sounds like you guys are right and I was wrong. So again, even though I've done lots of these and I felt confident that I could kind of take some shortcuts, you can see that that did not work out for me. Okay, I said I'd wait 10 minutes, but it's only been about 8, but that's still pretty close. Is there any of these questions that you guys are having more issues with, getting unstuck for? Yeah, what do you got?
7?
Okay, so on question 7, tell me what you tried
Well, I tried,
before that. Okay, go ahead.
so I turned the top to 3 times 1 minus sine x squared.
Okay, before that, what'd you do?
I plugged in pi over 2.
Okay, so you made sure it was 0 over 0. Did you start with direct substitution?
Yeah.
Okay, that's what I'm wanting you to say. Okay, you got 0 over 0. And so then you said you changed this to be what?
3 times 1 minus sine squared x.
That's what I would also do. Did you do anything to the denominator?
No.
Why don't you factor it?
Or,
You see that you could.
Or yeah, 2 times
Yeah, I turned it into 2 times 1 minus sin x.
Okay. So nothing cancels yet. It's tempting to cancel these, but you can't cancel out terms. So you got to do one more thing before anything will cancel, which was what? We did the same thing in question 6. We changed 1 minus cosine squared. We factored it as the difference of 2 squares.
I forgot to do that. My bad.
But if you do that, then I think you should be able to finish, because now something's ready to cancel.
You're right.
So as I've been saying, that's what's hard. Like, I know you can factor the difference of 2 squares, but always seeing to do it without being told is challenging. Okay, somebody else have one more question that you're getting stuck on? Yeah.
Number 4, you got 1, but I got negative.
What is your question?
Oh, just like, answer, I guess.
I got -1 too.
Okay, well you should check by graphing.
Oh yeah, let's check on that.
What did he get
Maybe you gotta change the sign.
I bet the answer, I bet more people missed this one and got it right though. So what was the less popular answer? -1?
The less popular answer was 1.
Yeah.
Then I'm going with 1.
Yes.
Okay, never mind. It's -1.
Is
Did you get 3 for 6?
it's the same.
I got 1 for.
What I suspect that
Or
the
7.
issue was,
Oh, I haven't done that yet.
Yes, I won! I won!
2/3.
I won bingo! Somehow.
Crap, I don't get the chips out.
I was like 6 shots ahead.
if that's going to be a distraction, then I'm going to take your phone.
Oh, I just didn't look at it.
I know, but this is a distraction.
My bad.
Here's where I think that this has come up in all of my classes so far today. When you FOIL this, numerator and numerator, the common mistake is that you do this, the outer and inner cancel, but right here, when you do the last part of FOIL, the square root of 4x minus 12 times the square root of 4x minus 12 is 4x minus 12. What happens when you do a positive times a negative, though?
Negative.
And if you write it like this, that is not correct, because it's not negative the first term. A positive one of all of this times a negative one of all of this gives you a negative of all of that. So you need to make sure that you subtract 4x and subtract negative 12. You don't just make the first term negative and not the other part negative. So that is easy to overlook. Make sure you add in the parentheses there, or just distribute. So I would say that's probably most of the mistakes on that question.
My calculator's tripping.
Okay, I'm going to set one more timer here. So another 10 minutes. I'll ask for a few more I can help you get unstuck from.
It calculates the little loading bar, but it's not loading anything.
Because you hit enter deposit or something.
Oh, yeah, okay, thank you.
We'll be asking for that number 65 next class. You guys really should have it finished today, but some of the other classes didn't quite have time, so I'm not taking it up yet. But on Friday, make sure you have 65 ready to turn in. Yeah.
Was there solutions on the website? Cause at least it didn't show up for me.
For 65.
Yeah.
There's a. Did you click the link for it?
Like there wasn't
Yes.
even a number 65. It just went to 64.
Did,
I don't know. It looks fine to me. I clicked it and it worked. Did you refresh the page?
I did on Sunday when I was looking at it.
Okay, I definitely didn't do anything since Sunday.
making sure that
Let's make sure we're looking at the same thing.
just that problem.
Yeah, it's there
Wait,
now.
but minus
Like,
4x
maybe it was
Wait,
just my
go back.
computer or
Or
something.
minus squared of 4x minus 12.
I don't know. If you had clicked on it maybe this weekend and you hadn't refreshed it,
Negative 4x
then maybe I hadn't fixed it yet or something. I don't know.
would be negative 1.
Negative
I don't know,
4x
there's like a lot more now.
minus, it would be
It
plus
was probably
12,
just my, like,
because,
computer.
Or negative 4x plus 12?
yeah.
Yeah, because I was trying to do it up here, instead of down here. It's just finishing on 65. This is 66.
It's both 66 and 67.
Wait a minute, wait a minute.
67 is the X.
Negative 4x for 16. Oh. 16.
No, you can celebrate that. You should go out and buy yourself a tiny cake. Really?
Your attitude.
I was being serious though.
What do I do? Ooh, I hate
What is it?
this. Took a little.
Oh, it's the Marvel Maze thing that you wrote in.
What's that for?
He's such a little kid.
Who said that? You?
No,
I said
the
it.
ghost behind me, Casper.
What'd you
I said
say?
it.
Well, shut your mouth.
I got negative 1 for 4.
Same. That one was weird though.
I gotta check 7 though, because I plugged it in. It didn't look like it was 3.
I'll try it.
I don't know exactly what.
No, I'm just.
Wait, do I have to follow this line?
Yeah,
I mean,
probably.
nobody's gonna arrest you if you don't, but I mean, that's how the game goes.
Oh,
God
crap,
dang it,
I
we
did
got
one.
20 minutes. Right, and then I got English, and I still have not read a single chapter of the Jungle.
Did the test today?
There's a test.
I was surprised
Oh,
that made
well,
it, to be
at
honest.
some point. I don't think it's today.
As much as I would like to.
There's a
read it,
quiz about it.
It's so nice to
Why do you have
read.
to read?
I don't have to go into.
I haven't read a single
it's
chapter.
not like I can't go to bed to practice.
Overall,
I can practice at home, but I usually have stuff to do at home.
that's
so-
trouble, man.
Completely fine with
I hope
it.
there's no, like,
I'm
specific
sure
stuff.
totally fine with
Mhm.
that. The only thing I'm not fine with is the shots the jack.
God, if there is, I'm gonna freak out.
For you all stage.
Jesus Christ, I cannot get
I'm
my
gonna-
B
I'm gonna-
in English.
Good. Done.
I guess I'll start listening to the audio.
If I have missed something to any section.
Isn't there something horrible?
Oh shoot.
I mean, to both of you, not about you. I somehow started on the wrong partial on my first scale, and like never had to recover because I was just like really stressed and wasn't really thinking. And I got my score sheet back, and you know how like you can get 16 for the scale on each edge. I got like a 1, a 0.9, and a 3.
I did it.
I didn't even get a point for one of them.
I actually did really good on my skills. The judge 1 gave me an 8 out of 8 for both skills, and
I don't know what H two is.
Yeah, we got it right on
7.3 and a 7.25.
It's just confusing.
Yeah.
I didn't check my
Maybe I
score
didn't
sheet
put it fast
actually.
enough, or I don't know. One judge gave me
How'd it go?
grade score.
Wait,
Another gave
My
me
keyboard is
really?
the worst audition I've ever done, and like I somehow balanced it out with Snare and Tiffany,
Yeah.
and I made all region, and I got a decent share.
Is that good?
Yeah, I got like 16th overall.
All region for Pitt High School, or what? Like, how does that work?
All region is like just like Northwest Arkansas.
Okay.
There's 9 in the state, and ours that we compete at is just like Northwest Arkansas, pretty much.
Is it like Northwest Arkansas,
So is it hard to
North,
make all
like
regions,
Central
or-
Arkansas?
It depends on the region, like, I
But when you
think,
do orchestra,
I think all region doesn't include Bentonville, and like Bentonville really has a lot of, that area has a lot of people that are
That doesn't.
really good at band, so that all region's probably harder, but for our
I'm still bitter at
region isn't,
the
isn't.
Don Tyson
How's that
School
hard?
of Innovation is pretty good.
So,
The Don Tyson School of Innovation is pretty good. So they don't have, they don't do marching band, they do band.
I'm pretty sure
So like
Herbert
they have
was.
first chair on
lifting
almost all of the instruments, except for like percussion and I think 2 or 3 others.
Yeah.
Herbert was second best at percussion. Herbert got the second
What?
in percussion.
I should have been second. Although our percussion program is the best in the state, so I'm not surprised.
You just said it 3 times 2 gives you this. Okay. Square root of 4x minus 12 equals 4x minus 12 is 4x.
What are you talking about?
We can run it with 4x minus 12 is negative. One is positive. So a negative times a positive, and all of that should be negative. So the way you have it written, you only have the 4x being negative. You need to distribute that and make that a positive. All of 4x minus 12 is negative. So you need parentheses. When you wrote it, you only made the first term, it's almost negative. It needs to go to all of it, because all of it. So that, it doesn't make a big difference, but it does mean that that's not plus 12, because these minus 12.
Yeah.
So it gets stuck shortly after that.
Okay, is there one more or two more I can help you get unstuck with?
Did you get 3 for 7?
I don't have the answers.
I got 3.
Pi over 2, yes, 3. Yeah.
Could you please show me number 3?
Number 3. Okay, so this one is definitely a conjugate one because it's got the square root piece in it. So you should have multiplied the top and bottom by square root of 3x plus 10 plus 2. Changing that middle sign is what makes it the conjugate. Shh, guys, please. We don't need to hear every little thought that goes through your head. The denominator. So we've got this stuff times this stuff, which we don't want to simplify. Just leave it that you're multiplying those two. But when you multiply the numerators together, you want to go through the FOIL process. Multiply the first two things together, which is what makes the square roots cancel away. If you want to do the outer and inner, you can, but those are going to cancel anyway. And then the last part of FOIL would be -2 times +2, which would be a -4. After that, you can go ahead and combine these two like terms. So instead of saying +10 minus 4, you could just say +6. And then you should know that something's going to need to cancel, because that's going to be the case for all of these indeterminate forms. So this is a lot closer to looking like this than it is to that. So that gives you a hint to do something else with this. And the something else would be factor out of 3. Then the x plus 2's cancel out. And so you're left with a 3 in the top. And if you plug this in down here, this goes to 4. Square root of 4 is 2. Plus 2 more would be 4. And so in the end, 3/4. So all of that's pretty quick. Is there something more specific? Any of those stuff?
No, I got it.
Okay.
Thank you.
It's not usually that any one step is difficult, but when these questions are longer like this, you got to do more steps correct without a mistake to get the final correct answer. So a little more demanding. Okay, you guys still have about 12 minutes. So if you see something else, feel free to call me over or to bring it up here. I would be happy to help.
Can Kristen and I play the Rubik's Cubers?
Are you both done?
Yes.
Do you know how to play it?
There's an instruction in there, right?
You gotta slide them until like you make the shape that's in the tiny box, right?
Yeah.
What are you
Yes, I read the instructions, that was about
There's an
very
instruction within
You
this.
try to make the thingy,
Yes.
you try to make the, like you shake it around and you try to make that sound.
Clip.
Yeah.
I can do it also.
We're even supposed to do that mini apparatus.
What?
That thing.
What thing?
The
What about it?
twist it. How does it work? Like, what do you do for
Put the
it?
ball at the start, and then you try to navigate around the holes and make it to the end.
Why is it so hard?
What do you mean, why is it so hard?
No, it's
If you
just,
could do it on the first try, then
Oh,
the thing is that like, it's just a little touchy.
Oh, no, you messed me up. That's not.
Go from here.
Oh wait, what is this one?
It's pretty cool,
No, it goes
actually.
this way and then.
There's a thing like that with
was
Zelda.
Alright, which one do you want to do?
It's, I don't know why it's so.
Oh, I thought we were gonna call it the thing.
Yeah, so you have to start off with the fact
That one actually fits. Huh. Most of the holes don't let the marble fit.
Yeah,
stripes.
this is actually hard. How do you do that?
Can we take these out?
No,
Yeah, I didn't see that far ahead. It's not supposed to.
How do you do
But
it?
like, to
you're
set
supposed
it
to
up.
slide it
So you
around.
shake it all, and basically, you have to put the center.
Or like,
Yeah. So like it would be.
I'm pretty sure it can be anything. Or yeah, it does that. And then when you're done, you have to
And then when
push
you're
it.
done,
Dude, I
you
love
do
this
this,
thing. That was-
and your middle has to match up with that middle.
It's so fun to spend. It's like fun.
Alright, can we take these out to set it up?
No,
You have to like set it up with that.
No, you slide it.
this is a different game.
Oh,
So where we put it from?
Okay, you're trying to make it look like that, the middle.
Like any way, right? Or does it have to be the exact way?
You need to make it look like that.
This is kind of, alright, ready?
Yes.
Because
Go. Whoa, why are you so fast? Alright.
it takes several minutes. It's not like you're gonna do it in 5 seconds.
I did this like once in 6th grade and I thought it was fun.
Yeah, it's fun. But it's not.
I'm not good at sliding puzzles like this.
Oh,
it's
I'm
not
good at
at all.
slide puzzles. I wanna go get somebody else in there.
It's harder than you think it
Red's
is.
way up there.
Yeah, you're good.
I'll play you.
I'm like this. I think you just slide the outside. Yeah.
Here.
I know, I'm sorry.
What?
No, you got it.
Yeah, you
had it.
You had it.
I did?
Yeah.
Where?
You got it.
It's
Yeah,
it.
slide.
Oh, I thought that was an old ribbon.
No.
Are you colorblind?
Are you?
The light was like reflecting
How
off.
close was I?
No.
I beat him. I'm better than Brandon.
I've never played
Oh,
this.
winner's days? Okay.
Oh, you just won. Okay, is that harder?
You got, 10 minutes.
Okay, I'll shake it.
He likes shaking a bunch.
Go. Doesn't have to be like upwards. It can be like sideways. If you're facing that way, it's I know that would be hard to make.
This or
What he makes. Instead of it like being the
Well,
like
his view has it's just because he
that.
he has to from position.
I'm not gonna be here Friday.
Okay. I need you to hand out at least, but
Okay.
you'll need to watch the class video to see what to do.
Yeah.
Dude, I think it's maybe some people were like just like
Yeah, there's some people that do it in like a minute.
the brains for their
I mean, look at Rubik's
Okay, I thought so.
More than 4 of the same color
Yeah. You got it.
How are you doing that?
Dude, I'm not winning.
How are you doing that?
You just do it in circles pretty much.
Yeah.
God. I guess
Shake it for us.
Shake it.
And hide it. Don't let me cheat.
What do you mean, me cheat?
I'm
What
gonna-
did I do that cheated?
I'm gonna win.
3,
Okay, go
2,
easy on me.
1. You already have 2. 3. Anybody called next one? I can actually do. Alright.
I need to
Why
buy
do you
wings.
keep letting this guy win?
How do you do this?
He's won twice in a row.
I think this might be the one thing he's good at.
I can't.
That's
Okay, that was actually
Yeah.
really offensive. And I need you to take that back immediately.
Okay.
He's not gonna win this one. That's too far away.
Yeah, so.
I don't know.
See
Wait,
the
what am I
mile
doing?
away.
What am I doing?
Yeah.
He's doing pretty
Got
good.
it right there.
I did?
No, Chris.
I can't do this. I was straight.
Sorry, there's a bunch of guys on the side.
You learn a couple, like,
Chris,
techniques
Jeff,
after you do it a
Christopher,
while.
Chris.
Have you done this before?
Have I?
You had it.
I did?
No.
I've
never
never
played
We
played
actually played this in advisory today.
But I keep mixing
I'm
these up.
pretty
good at like the, like 3x3 slide puzzles.
Are you good at
Or
it?
the 4x4.
Oh.
Not really. When I played earlier today, I lost one and won one.
Hey, you won one though.
When I played, I had these two right, the top two, and then I spent like 5 minutes trying to get the bottom one
I
correct.
did?
I just
I
got
had a lot to start off with.
like a
You had it. You
writer's
had
block.
I just can't do this.
Do it, can
He
Why-
has.
why is the-
He had this side.
Mixing that up.
I don't have the technique.
He doesn't know the fact.
I like when people like move 3 in a circle and just keep on doing it.
Yeah.
That's what I'm doing.
Why?
I can't. I don't know.
You gotta force yourself to like break it up and do something different.
You gotta go all the way around.
Well, like sometimes I'll accidentally do one extra, and then I'll just do it again, and then I'll do it extra again, and then I'll do it again.
Oh, it's too red.
How am I meant to get the red there? There we go.
Yeah, and then go all the way around.
Hold it like that a little bit. Sorry, that's the.
Oh, you could put it. And then wipe it.
Wait, but
Oh,
no. Oh, okay. That's,
Didn't think about that.
And I'm-
Yeah, you're done.
No, you. Oh, yeah. There he is, yeah.
that was your worst performance.
Yeah, I tried getting these 3 right, but it was just 4 right.
I got
I'm going
help.
after Brandon.
I got help.
He's going after me.
I wouldn't have won that.
Right.
I'm gonna get
You
this.
said 4 of the same one?
Yeah.
There's 3 of everything.
Wait, hold on.
Wait, wait, you can do the whole thing.
3.
Did you lose?
2.
Yeah, I
one.
finally lost my third
Okay.
round. I pretty much kept going in circles for my
Like a racehorse.
bottom right.
Yeah, Diego's doing it.
No, I'm not.
Sometimes if I can get like find the right three together, I'll just like move like two lines, like one at a time, you know, and then like slowly shove them all in the right direction. But it's hard. See, when I was a kid, there used to be these little like plastic
The faster
games
you go, the better you do.
like that, and I think they had numbers like 1 through 8, and so like you would like try to rearrange them 1, 2, 3, 4, 5, 6, 7, 8. You know what
I did those all the time.
Yeah, yeah.
Kinda
To
good
me,
advice.
it's the same idea. Yeah. And then like if you did that, then you could try to do it backwards or whatever.
The worst thing was, on that round, I'd already